A $500,000 GPS-guided tractor just broke down in the middle of harvest because the software subscription expired. The dealer is 3 days out. The field is dead. 2 rows over, a farmer on a machine with no computer, no screen, and no Wi-Fi signal is still cutting. He has been cutting since 6 a.m. The old machine doesn't need permission from a satellite to do its job. That gap between what technology promises and what iron actually delivers is what this list is about. Number 10. The new Holland Haybine Model 460. Before 1964, making hay was a 2-step operation that cost farmers time they didn't have. First, a sickle mower would cut the standing grass or alfalfa. Then, on a separate trip through the same field with a separate machine, a conditioner or crimper would crimp and crush the stems of the cut hay to accelerate moisture loss so it could dry faster before baling. 2 machines, 2 passes, 2 sets of maintenance, parts and PTO connections, twice the fuel, twice the time. In 1964, New Holland changed everything with a single machine, the Haybine Model 460. It was the world's first combined sickle mower and conditioner, a machine that cut hay and conditioned it in one single field pass. The sickle bar cut the standing crop cleanly at the base. The crop immediately passed through a pair of rubber conditioning rolls, the iconic chevron-patterned rubber rolls introduced on the Model 461 in 1966, which crimped and crushed the stems, opening them up to let moisture escape rapidly. The result was hay that dried significantly faster than hay cut with a sickle mower alone, dramatically reducing the window of exposure to rain and weather that every hay farmer feared. The name Haybine was trademarked by New Holland, and it became so synonymous with the concept of combined mowing and conditioning that for decades, farmers across North America called any mower conditioner a Haybine, regardless of brand, the same way people call any adhesive bandage a Band-Aid. That is the measure of how fundamentally the 1964 Haybine reshaped a category of farming. New Holland continued developing the line through the 460, 461, 469, 479, 488, 489, and beyond, maintaining the core design philosophy across 59 years of continuous production. The last Haybine Model 488 rolled off the line in 2023, when New Holland officially discontinued the sickle bar mower conditioner after the transition to disc-cut mowers finally made the category commercially unviable. But that transition took nearly 60 years, and for most of that time the Haybine was the dominant hay-cutting machine in North America. Number 9. The Massey-Harris No. 21 Self-Propelled Combine. Before 1941, grain harvest in America operated on a fundamentally communal model. The threshing ring, a rotating cooperative of neighboring farms, would pool labor and equipment to run a stationary threshing machine from farm to farm across a region. When the thresher arrived at your farm, 15 or 20 neighbors arrived with it. The grain was cut, bound into sheaves, hauled to the threshing machine, and fed through by hand. The process fed and employed dozens of people simultaneously. It was also completely dependent on weather, labor availability, and neighbor cooperation. Massey-Harris engineer Thomas Carroll had been working since 1937 to perfect a self-propelled combine, a single machine that could reap, thresh, and clean grain in one pass across a field, powered by its own engine, operated by a single person. The number 20 of 1938 was too heavy and expensive for widespread production. The number 21, tested in 1940 and put on sale in 1941, was the machine that finally made it work. It was lighter, it was more affordable, and in 1944, Massey-Harris demonstrated the machine's revolutionary potential with something called the Harvest Brigade, a fleet of 500 Massey-Harris self-propelled combines that moved north through North America following the harvest, custom-cutting wheat across the Great Plains in a single coordinated campaign. The Harvest Brigade of 1944 is recognized as the beginning of the custom harvesting industry in America, a business model that still exists today as teams of custom harvesters move north with the wheat harvest each summer. Number 8. The new Holland Automaton Square Baler. The history of the self-tying pickup baler begins with a Pennsylvania farmer and threshing machine operator named Ed Nolt, who in the winter of 1936-1937 began building a baler in a small shop in Kinzers, Pennsylvania. Nolt had watched the small combine harvesters arriving on the market put his threshing business at risk. and he recognized that the straw those combines left in the field created an opportunity. Livestock farmers needed that straw for bedding, but baling it efficiently required a machine that could pick up windrowed material from the field, compress it, and tie it automatically without requiring workers to hand-tie each bale. Nolt's most critical engineering achievement was the telescoping connecting rod, a mechanism that kept the plunger in contact with the bale while it was being tied, maintaining compression and producing a tight, consistent bale. That single innovation was the only patentable feature of the entire machine, but it was the key that made automatic tying possible. 5 balers were built in 1938. By 1940, production had moved into the New Holland factory, and the machine was renamed the Automaton. In 1941, the number 75 Automaton sold for $1,775 and could handle 3 to 6 tons of material per hour. The timing was perfect and catastrophic in equal measure. World War II had already begun pulling farm labor off American farms and into the armed services. The Automaton baler allowed farm wives, children, and elderly workers to handle hay operations that had previously required strong adult male labor. The 16 by 18-inch twine-tied bales it produced, weighing 40 to 80 pounds, were light enough for women and older teenagers to handle. The machine's arrival in 1940 and 1941 may have literally saved American hay production at the moment when the country needed that production most. New Holland had introduced the industry's first self-tying small square baler, and the rectangular bale of hay that became the global standard for decades after the small square bale that every child ever asked to help stack was the direct product of this machine. The concept of the self-tying pickup baler is still in production today through New Holland, John Deere, and others, essentially unchanged in its fundamental operating principle from what Ed Nolt assembled in that Pennsylvania shop in Number 7. The Ford 8N tractor. Official production of the Ford 8N began in July 1947 at Ford's Highland Park, Michigan plant. By 1952, when the last one rolled off the line, 524,076 units had been sold. By North American sales figures specifically, the Ford 8N is the most popular farm tractor of all time on the continent. Nearly 75 years after the last one was manufactured, parts remain universally available. A full aftermarket ecosystem supports every repair need, and 8Ns are still pulling implements on working farms from coast to coast. The 8N was born out of the collapse of the famous handshake deal between Henry Ford and Harry Ferguson, which had been the foundation of the earlier 9N and 2N models. After Henry Ford died, his grandson Henry Ford II discovered that Ford Motor Company had lost over $25 million on tractor operations across 6 years. Despite commercial success, the price had been set too low. Ford too formed Dearborn Motors to take over distribution and informed Ferguson that Ford would no longer supply tractors to his company after July 19. Ferguson sued for $251 million in damages. The 8N was developed as the independent Ford tractor that would replace the entire arrangement. The 8N improved on its predecessors with a 4-speed transmission rather than 3, increased PTO and drawbar horsepower, a new position control hydraulic system, independent brakes on the right, and the clutch moved to the left, all packaged in an elegant two-tone red and gray paint scheme that remains instantly recognizable. The 2.0-liter 4-cylinder gasoline engine produced approximately 27 horsepower at the drawbar. Simple, reliable, and repairable with tools found in any farm workshop. Number 6. The Gleaner Model A. Self-propelled combine, the Gleaner Manufacturing Company was founded in 1923 by 3 brothers, Curtis, Edwin, and Ernest Baldwin, in Nickerson, Kansas. They were custom harvesters themselves, men who moved north following the wheat harvest each summer, and they understood exactly what a combine needed to do in the real conditions of a working field. Their machine was named after Jean-François Millet's famous 1857 painting, The Gleaners, 3 women in a recently reaped field collecting leftover grain, the idea being that a gleaner machine would harvest so completely that nothing remained to be gleaned afterward. From 1923 through the late 1940s, Gleaner produced pull-type combine harvesters. In 1951, they introduced the Model A, their first self-propelled combine, and it embodied engineering principles that were genuinely different from every other machine in the market. Gleaner was the first combine manufacturer to use galvanized sheet metal on its body. eliminating the need for paint in environments where dust storms and weather conditions wore paint off quickly. The silver color became Gleaner's permanent trademark, a design decision made entirely on practical grounds that lasted for decades. Gleaner also pioneered the Rasbar threshing cylinder, a design that replaced the spike tooth arrangement used by other manufacturers, which provided more consistent threshing with less grain damage. The most distinctive Gleaner engineering principle was the down front cylinder placement. The threshing mechanism was positioned close to the header, reducing the distance the crop traveled between cutting and threshing and producing more consistent grain quality. This remains a Gleaner design characteristic to this day. Allis-Chalmers acquired Gleaner Under Allis-Chalmers' ownership, Gleaner grew substantially, introducing the Model C in the early 90s, which became popular with custom harvest crews who could equip it with headers from 14 to 20 feet wide. When Allis-Chalmers was sold to Dodge in 1985 and ultimately became Axial-Co, Gleaner was part of the portfolio. Axial-Co itself stands for Alice Gleaner Company, a name that acknowledges the Gleaner heritage in the very corporate identity of one of the world's largest agricultural equipment manufacturers. Number 5. The International Harvester 1460 Axial-Flow Combine. On a rainy day in 1977 at the Farm Progress Show in Washington, Iowa, a demonstration unit of the International Harvester 1460 Combine earned a nickname that followed it for decades, the Red Demon. The machine had been performing in muddy, wet, difficult conditions that were shutting down every other combine at the show. The 1460 just kept working. The nickname was not ironic, it was a tribute. The 1460 introduced what IH called the Axial-Flow system, a single longitudinal rotor that performed both threshing and separation in one continuous process, replacing the conventional design of a drum and concave for threshing followed by straw walkers for separation. Development of the concept had begun at IH in the 1950s, when laboratory research showed that the open concave and cylinder were more efficient than straw walkers for separating grain. Engineers worked for more than 20 years on the concept before the 1440 and 1460 entered production in 1977, with an initial output of 300 units at the East Moline, Illinois facility. IH had patented the rotary design, giving them a significant competitive advantage over rivals including John Deere, Massey-Ferguson, and New Holland. The practical impact was extraordinary. The rotor system had more capacity than drum and walker designs of equivalent size, produced less grain damage because of the gentler grain-on-grain threshing action, handled heavy wet or down crop conditions far better than conventional combines, and was mechanically simpler with fewer moving parts and belts. When John Deere sent engineers to evaluate the 1460, reportedly purchasing one from a Minnesota farmer who'd been among the first customers, they recognized immediately that IH had fundamentally changed the benchmark. Deere spent years developing their own competitive rotary response, the Axial-Flow design. Originally patented by International Harvester, passed to Case IH after IH sold its agricultural division in over 160,000 Axial-Flow units have been produced. The Case IH Axial-Flow 250 series machines in production today, with engines producing up to 400+ horsepower, are the direct technological descendants of that The single-rotor Axial-Flow principle has been in continuous production for nearly 50 years without fundamental replacement because the principle is correct, and the engineering as executed in Number 4. The New Holland 850 round baler. Until 1974, hay storage followed a pattern that had existed since the invention of the self-tying square baler, rectangular bales, 40 to 80 pounds each, requiring multiple people to load, stack, and store. The economics were manageable when farm labor was plentiful. As that labor became scarce and expensive through the 1960s and 1970s, the limitations of the small square bale became a genuine agricultural problem for livestock farmers who needed large quantities of forage. New Holland's answer, unveiled in 1974, was the Model 850 round baler, a chain and bars machine with an imposing industrial appearance and no sheet metal covering, producing a bale approximately 150 centimeters in diameter. The round bale it created weighed hundreds of pounds, could be shed stored or left outside in the field for short periods, and could be moved by a single operator with a tractor front loader. The labor arithmetic changed immediately. One person with a round baler and a tractor could accomplish what previously required multiple workers for square baling, plus additional workers for stacking and storage. New Holland began producing haybines in 1964 and round balers in 1974. And these two innovations together essentially defined the modern small to mid-scale hay operation. The 850 was replaced by the 851 in 1978, and the model line expanded rapidly through the late 1970s with the 852, 849, and others. In 1989, New Holland introduced the 630, the first roll belt baler, which replaced the chain and bar mechanism with belts, improving bale density and speed significantly. Over 275,000 roll belt balers have worked around the world, all of them building on the concept that the 850. Since 1974, New Holland alone has produced more than 50 round baler models. The round bale in its various forms is now the dominant hay storage format globally for livestock operations of all sizes. The concept of one-person baling and moving large quantities of hay without assistance, which the 85 made commercially viable for the first time, is now so fundamental to livestock farming that it is impossible to imagine the industry operating without it. That shift started in 1974, with chains, bars, and no sheet metal covering in a Pennsylvania factory. Number 3. The John Deere 7000 MaxEmerge planter. Before the John Deere 7000, corn planting was a process burdened by inconsistency. Plate-type seed meters, the dominant mechanism in planters before 1974, used a rotating plate with holes or cells to pick up individual seeds from the hopper and drop them into the furrow. The system worked, but the seed spacing was variable, the depth consistency was imperfect, and the plates required different configurations for different seed sizes, a time-consuming change for a farmer who might be planting several different varieties. In the fall of 1974, for the 1975 selling season, John Deere introduced the 7000 MaxEmerge planter and the concept that revolutionized corn planting, the finger pickup metering system. Instead of a plate with holes, the 7000 used flexible fingers that individually picked, oriented, and released seeds, handling each kernel as an individual object rather than using gravity and momentum to push seeds through holes. The result was more consistent seed spacing, more consistent seed orientation in the furrow, and the ability to handle different seed sizes without changing the entire metering mechanism. Alongside the finger pickup, Deere introduced the TruV opener system on the 7000, a pair of angled disc blades that cut a clean V-shaped furrow through the soil with consistent wall integrity. The seed dropped into a formed trench rather than a ragged opening, and consistent trench geometry meant consistent seed-to-soil contact, which meant more consistent germination timing. The planter was also Deere's first commercially successful no-till design, with coulters that cut through crop residue ahead of the furrow openers, enabling the 7000 to plant directly into corn stubble or soybean residue without prior tillage. Deere & Company's Henry Ford Museum Collection artifact listing confirms the 7000 no-till version as the first commercially successful no-till planter. Introduced in the 7000 was produced from 1974 to 1986. The finger pickup metering principle it introduced remains the foundation of row crop planting technology today. John Deere's current ExactEmerge planter system, capable of planting at 10 miles per hour with individual seed control on every row, traces its direct lineage to the finger pickup concept the 7000 proved in The TruV opener remains a standard option on planters across multiple manufacturers. The no-till concept the 7000 commercialized is now the dominant planting practice on millions of acres of American cropland. Over 171 listings of John Deere 7000 planters remain available for sale as of 2026. They are still being rebuilt, still being fitted with modern precision seed monitoring systems, and still planting corn across the American Midwest. Machines that are 40 to 50 years old, still capable of doing the job, still supported by an active parts market, and still producing acceptable yields in the hands of operators who know them. Number 2. The New Holland Automaton Descended Small Square Baler 66 Series. The chain of development from Ed Nolt's 1937 prototype to the New Holland automatic pickup baler line is one of the most direct lineages in farm equipment history. After the Automaton entered production in 1940, New Holland, which became Sperry New Holland after a corporate restructuring, continuously refined the small square baler through the 1950s, 1960s, 1980s into a line of machines that became the global standard for hay production. New Holland's 66 series and subsequent balers of the 1950s and 1960s were so reliable and mechanically sound that they spread to every agricultural region on Earth. The loop master knotting system, which New Holland developed and which produces a knot with 37% stronger loop knots than standard knots, became a defining technological advantage. The system could tie consistently and quickly at high throughput rates without the frequent misties that plagued earlier balers, dramatically reducing the labor required to monitor and retie improperly knotted bales. Throughout the 1950s and 1960s, New Holland square balers were the global sales leader in haymaking equipment. They established the 36 by 18-inch bale as the standard small bale dimension that hay handling systems, barn storage designs, and feeding equipment were built around for decades. When competitors looked at how to design hay handling systems, elevators, throwers, wagon systems, they designed for the New Holland bale because that was the bale the market was using. The enduring truth about small square balers is that they never became obsolete for every application. Even after round balers arrived in 1974 and large square balers in the 1980s, certain livestock operations, particularly those with multiple small animals fed individually, or operations with barn storage systems designed around small bales, still prefer and use small square bales because they are more manageable, can be transported in smaller vehicles, and can be fed without bale processors. In many parts of Europe and Asia, the small square bale remains the dominant hay format because farm and barn sizes make it the practical choice. New Holland and John Deere continue to manufacture small square balers today, still using the essential principles that Nolt assembled in a Pennsylvania shop in 1937. Number 1. The Ferguson TE20 3-point hitch. There are inventions that change their industry, and there are inventions that become the industry's foundation. The Ferguson hydraulic 3-point hitch system, introduced to mass production on the Ferguson TE20 in 1946, built in Coventry, England by the Standard Motor Company under license from Irish engineer Harry Ferguson, is the latter. It is the single most important engineering development in the history of the farm implement, and it has never been replaced. Not improved to obsolescence, not superseded by something fundamentally better, not phased out or retired. It is still in use, in its original essential form, on every tractor manufactured anywhere in the world in 20. Harry Ferguson began developing the concept of the hydraulic 3-point linkage in 19. He was a farmer's son from Northern Ireland, and he understood from direct experience that the critical problem in attaching implements to tractors was not power, it was control. Heavy implements attached to tractors of the era would either dig uncontrollably into hard ground or bounce over soft ground, wasting power and producing inconsistent tillage. Worse, if a rear-mounted implement hit a buried rock or fixed obstacle, the tractor could rear violently, a deadly hazard. Ferguson's solution was a converging 3-point linkage, two lower arms meeting the implement at points wider apart at the implement end than at the tractor end, combined with a hydraulic system and a draft sensing mechanism that automatically adjusted implement depth based on the pulling resistance the tractor experienced. The draft control element was the breakthrough. When the implement pulled harder, encountering denser soil or harder ground, the hydraulics automatically lifted it slightly to reduce load. When it encountered lighter soil, the implement lowered to maintain consistent working depth. No operator input required. The tractor managed it automatically. Ferguson spent 19 years refining this system before it entered commercial production on the Ferguson Model A in 1936, built by David Brown in Huddersfield, Yorkshire, and reached global scale on the TE20 in 19. The TE20 was produced at Banner Lane in Coventry from 1946 to 1956, with 551 units built. Combined with the American TA20 production and all Ferguson system tractors from 1936 onward, total production approached 1 million machines. The TE20's 3-point hitch and draft control were adopted as International Category 1 standard hitch specifications, meaning every implement built to Category 1 specification worldwide was designed to attach to the geometry that Harry Ferguson defined. That standard still governs implement design globally. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.